All right, so if I can grab my panelists, please. Ryan, Beatrice, and Kim. Excellent. And I'm gonna sit down here. I don't like the podium. Let's see, does this work? No. Oh, technology. Let's see, aha, there we go. All right, while everybody gets set up on the microphones, I will introduce myself and a quick overview of this panel. As Jeremy noted, you guys have been hearing a lot about AI. And honestly, you guys have been using AI a lot, the folks in this room, for years and years and years. My name is Heather West. I am on the cybersecurity services team at Venable, and I work with the Alliance for Trust in AI to talk about AI, and very, very particularly talking about what makes it more trustworthy, what makes it more of a tool in our toolbox to think about as we move through this new technological world of ours, and throw new marketing terms at some of it, and then also talking about what is actually new and how we can think about this. So with me today, I have Kim Soffen, who is the Legislative Director for Representative Foster, who is moving a bill on digital identity through. I have Ryan Galluzzo, the Digital Identity Program Lead for the Applied Cybersecurity Division at NIST. And I have Beatrice Moisinak, who is a data scientist at Okta. So I'm very excited to have this chat today. So thank you all for joining us. And so let's start with talking about how AI is used today. We're seeing sophisticated attacks on identity tools impacting call centers, the financial sector, health services. Identity is used across all these sectors, as this room well knows. Companies and governments are thinking about identity proofing and how we can protect those systems. Kim, I know there are a lot of important reasons to pay attention here. Can you talk about a few recent examples of why this is so important?
Sure. So is this working?
Do you have lights on the front?
Yeah.
It should pop in.
Okay, hopefully it's working.
Cool.
Yeah, so I mean, most recently, what we took note of on the political end were the deep fake calls that went out from a fake Joe Biden telling New Hampshire voters not to vote, which is obviously super problematic going into the 2024 election cycle. The other thing that is really on Congress's mind right now is like deep fake scam type of threats, like, oh, I got like a call or a FaceTime from someone who like appears to be my son saying, hey, I'm in trouble. Can you send me $1,000? And if you're not a super sophisticated person technologically, that can seem pretty compelling. So that is kind of the other example that we thankfully haven't seen too much of yet, but seems just around the corner that Congress is really keeping an eye out for.
Thanks. Ryan, I know you're thinking a lot about the trends that we're seeing in digital identity in terms of AI. Are there examples worth raising, kind of key indicators?
Yeah, I mean, I think there's a couple things to think about when it comes to how AI is used today and what we see as trends. I mean, there's the adversarial side, some of the things that have already been talked about a lot today, both with Kim right now and also with some of the conversations around things like phishing attacks, deep fakes, morph attacks, which is when you're kind of combining images of a legitimate user with an illegitimate user trying to defeat biometric matching systems. There's a lot of different approaches that can be taken to on the adversarial side, and I think we've talked about those a lot. But the other thing is that AI and machine learning have been used pretty extensively within the identity space for quite a while now, right? A lot of times when you talk about biometrics and biometric matching and face recognition and verification, you're actually talking about systems that have started to use AI and machine learning a lot. So my colleagues over at NIST who work in the face recognition vendor testing program, which is now the face recognition technology evaluation program. They've talked about how they've seen this kind of, we've been talking about hockey sticks for the past little bit here, and I love hockey, so I'm going to keep with it, but these kind of exponential rises in the performance of face recognition systems. And that's where we're taking, and systems are taking these large data sets and being able to use them to, continually improve their biometric algorithms from an accuracy perspective. So, we've got the adversarial side, but we're using this to a lot of value, I think, as well on the defensive side or on the proactive side from an identity perspective. We're also seeing a lot of use in these kinds of systems when it comes to identity verification and fraud reduction, looking at large data sets and being able to try and identify where you've got trends that may indicate that there's been a fraudulent transaction or that a potential user may have been compromised. So there's it's an arms race between what's happening on the kind of adversarial side as well as on the defensive side. And I think making sure that you also think about it from the perspective of not every application of AI and machine learning is generative AI. There's a lot of different ways to look at this, and there's a lot of techniques that are applied to actually improve things that we don't always think about as being AI and machine learning.
I think that's a really important point. And as I told you before, one of the things I think is incredibly important is differentiating between the kinds of AI we're talking about here. Because if you say AI in DC, everyone assumes you mean generative AI and very specifically ChatGPT. And those are really interesting tools that have applications in this space, but they are far, far from the only piece of AI that is really impacting what we're seeing here. Beatrice, you and Okta are really on the ground, working through all of these threats, identifying, defending, mitigating, innovating. I'd love to know what you're seeing, especially in the consumer side space, on the enterprise space, basically any observations about what AI means.
So I completely agree with you in terms of the application of AI. We have been using it for quite some time now, and not generative AI, but your good old linear regression, very useful. That is an AI. In essence, whenever you hear AI, I want to define it for people. It's a decision that is made by a computer that by its smartness is undistinguishable from a human decision. So the trick here is that oftentimes we are going to use, so here at Okta, we're using data in order to learn those rules, those smart decisions that the model can make. And when you are an authentication server, like we are on the customer side, you can't do that. I can't just sit down my security expert and ask him, write me a rule right now to detect the bots. It has to be done at scale for the millions and millions of authentication requests we get. So without the scalability of those probabilistic models, we would not be able to do it. And what we see is that, it's using fire against fire in a way, well, some math model against some other math model, really, is that they do have a drastic effect, most notably a deterrent effect at, fighting credential stuffing, sign-up attacks, SMS call pumping, like whatever you have, I have it. Like everybody wants to get into people's accounts, so it happens. But therefore, we need to have those very sophisticated mathematical tools that are called AI in order to fight it.
I really love the dichotomy of the good guys and the bad guys, both using the same tools over and over and over to see what can be done. But on a different good guy note, Kim, can you tell us a little bit about Representative Foster's digital identity bill and how you hope that it can help move the ball forward and make it easier for all the good guys in this room?
Sure. So we have a couple different things moving. If you're not too familiar with how congressional politics work, it's all about fitting things into specific committee jurisdictions because no one likes to share. So that kind of unfortunately makes our bills a little bit unwieldy and occasionally a little bit irrational to make them fit into the buckets they need to fit in to actually be able to move. So the kind of two different approaches we have going are a bill that we've been introducing for a while called the Improving Digital Identity Act. The main kind of focus of that is to convene a lot of different government agencies onto a task force that can then come up with recommendations that the rest of the government can implement. And there was also a NIST piece of that asking for a standards update in some respects, and that actually passed as part of the Chips and Science Act previously, which was great. So that's kind of one side. The other side is coming at this more from the banking perspective. So obviously banks have a big vested interest here, as I'm sure we'll hear later with FinCEN, making sure that the person who opens the account is actually the person they say they are. So coming from that angle and saying how can Treasury kind of lead the way in encouraging states to adopt digital IDs, or even perhaps the federal government helping the states that are lagging behind and allowing people to get IDs themselves. That one is still kind of under negotiation with some Republicans. But that is those are the two approaches we're taking. So number one is this task force, and number two is starting with Treasury and the banks and kind of letting it expand across the economy from there.
Thank you. Ryan, NIST is doing a lot of AI work, and I will say for the benefit of the room that you're involved in some of it. And I'm not going to ask you to speak to the broad strokes, even though I'm very excited about it. Can you talk about your role in the Applied Cybersecurity Division and what you are thinking about in terms of this particular nexus?
Yeah, so and to what you alluded to, we have an entire AI team that has been heavily empowered by the recent executive order around AI. They're the folks who helped develop the AI risk management framework, which is seeing some pretty decent adoption in the space. I'm not part of that team, and I'm definitely not going to attempt to speak for that team. But what I can talk to is what we're doing, not just in the Applied Cybersecurity Division, but kind of more broadly across our information technology lab. So those of you who are familiar with this, which I think most people are, we've got the information technology lab is where all our divisions sit that deal with computer science, computer security, applied security, and all that other stuff. And so that covers everything from our NCCOE, which is the Applied Cybersecurity Division, to our privacy and security work that's under the the Applied Cybersecurity Division. It also covers folks in our Information and Access Division who own and maintain our biometric comparison programs and our biometric testing programs. So we have a broad set of folks that we like to apply to all these use cases, and particularly once we start talking about identity, we're really starting to look at how we can think about these things as kind of a data challenge and a data problem. So, on the side of the folks that run our biometrics program, the thing they're looking for is how do we make sure that we've got the sets of data that we need in order to be able to continue to train and test. And so not just training, but also testing to evaluate the efficacy. How do we make sure that those data sets are representative of the end user populations that are going to have to leverage these technologies, right? Because one of the other major concerns with all this is the biases that might be inadvertently introduced. We've all heard plenty of conversations about challenges in face recognition technology performance across different demographic groups. So how do we make sure we have the right data on our side to keep testing? How do we help organizations that are looking to get that data to help train their algorithms? How do we get that to them or help them gain access to that? And then thinking about as well, too, the privacy challenges that go alongside that. You have massive amounts of data that you're trying to use to train these algorithms. You need to make sure that that's been collected in a way where the user understands that what they're submitting to you is not just going to be used for whatever might be your typical access scenario, but hey, we might also be using that to train an algorithm, or we might be using that for another purpose to help improve our AI system. So making sure that you've got that ethical approach built in, making sure you're using that AI risk management framework. Then also, how can we apply things like privacy enhancing technology explicitly to build in that kind of the identification up front. So we've got our colleagues, Naomi Lefkowitz, who runs our privacy engineering team. She has an entire program focused on de-identification of data. They actually have a collaborative research cycle, which is a program where you can submit your de-identification algorithm to them to get it tested and make sure that you actually don't have the ability to kind of backwards engineer and re-identify these data sets. So we have that work going on. They also have work that's going on with our colleagues in the UK around synthetic data. So how can we potentially apply synthetic data to these use cases so we don't have as many privacy problems? Obviously, there's a lot of challenges with that in the identity space because these technologies are supposed to identify synthetic data and not allow it to get through. So how do we build the right sets to help individuals actually kind of train their programs, or organizations rather, train their programs? From an 863 perspective, we're really looking at the testing and evaluation side of the house when it comes to how these are used in identity solutions, right? We're not going to be able to create innumerable bouts of requirements for all the potential applications of AI and machine learning. There's just too many. So we really want to focus on making sure that you're testing those kinds of technologies from an algorithm level, the ground up, in an operational scenario. So not necessarily all of your user base, but bringing in a user population that is representative of those users that you're going to have and run it with them, and then evaluate over time to make sure you don't have inadvertent issues of bias or discrimination within your systems that leverage AI. And if you do, find ways to action those and adjust them. correct them. That's some of the things we're working on right now.
Sounds super simple. Not really. I think that that's such critical pieces that the government can contribute to here, and really making this better. I think the panel earlier about what happens if the government doesn't act. I forget. I'm paraphrasing the title, but I loved the title. I think this is a good demonstration of excellent places for the U.S. government to be working. Let's talk a little bit about how AI is being used today, a little bit more. And in particular, Beatrice, I'm really interested in this piece of the puzzle. How do you take a threat and turn it into your own tool? Can you talk about what you're doing at Okta and what you see in the space?
Sure. So Okta, for everyone, and specifically for the part of the small bit of Okta that I work in, which is the customer identity management part, you go on your phone right now, you go on some website, that a retailer, for instance, you log in, and this is where I magically appear, and I check, are you who you are, you say you are. Actually, it's not me, it's the algorithms that will do that. So the authentication server is the bit that receives a request to log in and then decides whether this is you or not. And we have seen passwords are useless. Use your passkey. Sign up right now. Go sign up your passkeys. We have them. But if you do have a password, well, how do I really know that it's you? There are other things in the URL request that you are sending from your phone. There are other things that we can look at. And so where AI is great, in particular, all of those very advanced statistical models can look, instead of looking at one thing, we look at the horizon, the forest of all the trees, and we look at if I may say, the color of the forest, right? Do you look like all of those people who should look statistically like people versus those who look like bots, who statistically in the distribution looks like bots? So AI in general, and a lot of statistical models in particular, are helping scaling this effort to detect what are the statistical aspects, parameters, features that define an attack, right? So of course, then sometimes it's very easy. Oh, you're trying to connect 1,000 times per second. Fairly certain you are not a human, but oftentimes it's not actually that easy. And if you have a botnet and if you have a smart appliance, please disconnect it from the internet. I am swamped with IoTs trying to do credential stuffing. So, if you're a dishwasher, I can tell it you are not a human, but sometimes it's a little bit harder. So AI helps with that, actually, trying to identify what are those patterns in the data that are fluid as well, because the problem is that, today I come up with a model, tomorrow the attacker will say, aha, she figured it out, let's move on. And so we always have to be in those, it's called a self-healing model, right? So a model that itself can move with the trends in the data that we see. And that is not something that we can do at human scale. It has to be a computer going at computer speed against the other computer.
You're telling me I can't figure out it's a dishwasher? Probably can't. I actually think it's a very interesting exercise. And Ryan, as you're talking about some of the testing pieces, and Beatrice, as you're talking about, AI being particularly good or better at figuring out who is and isn't credible and a real person online, those differentiations. I think the New York Times had a little quiz series in the last couple of days. Is this face AI generated? It turns out I'm really bad at that game. But I'm really glad that there's some tools that are much better at it, whether it's a face or transactions and interactions. I was just like stunned. I did significantly worse than 50%. I should have, if I was just random, done much better than I did. And so it was a very interesting piece of this. And Beatrice, I'm interested, I'm assuming, but tell me if I'm right, that these tools can really be tuned to be very, very specifically looking for those exact indicators that I'm not finding in those AI generated faces.
So let me give you an example that I had in graduate school. It's the canonical example of what's happening. They took pictures of insects when they were preserved in some jello, and they wanted to create an AI that recognized the insects. And what they realized after months and months of not figuring out why it was either way too good or way too bad, it's that it actually learned to locate the little bubbles in the jello instead of the insects. So those and that actually they've studied how humans recognize human faces, right? We look at the eyes, the face, the shape, etc. And it depends which ethnicity you are. Like, it's very interesting. But bots, they don't have all of that cultural background that shapes the human mind, right? Instead, they will look at probably the background that you have in your picture, like other things that are not present. Every time I see an AI generated picture, I'm trying to ask myself, is this an AI generated picture? I'm trying to think, is this something I would see in a dream? Because it's like, it has this eeriness of not being quite real, right? With 6 fingers, etc. But if there is no fingers, how do you do it, right? So it is trying. There is pattern in the image that you do not see because you are not, trying to optimize a loss function somewhere. So you don't have it. But this is where we need the machines to fight machines, because they are looking at things where we are stuck in whatever cognitive schema we have. We can't fight that.
Ryan, can you talk to some of the similar ideas, how AI is being used to improve, identity systems very broadly? I know we mentioned generative AI. We can set that aside. But what you're seeing in using these tools?
Yeah, I mean, I think aside from the biometric side of the house is where I think, at least we see a lot of the more kind of rapid and measurable responses to what we say elsewhere. We've heard about a lot of it today. I mean, we're seeing it in the perspective of being able to attempt to identify almost the exact opposite of what the fishers are doing, is looking, building machine models that are actually going to be able to identify when something looks like a suspicious or phishing related phishing scam. We've got a lot of work being done right now into how we identify and understand, and scan documents, right? So a lot of these tools are being applied to how do we build the right kind of templates to be able to evaluate whether or not a document is a legitimate document. And we've got the verification or the certification program that's run right now through FIDO on the document verification. We've also got our colleagues from DHS here who are running the Riveted program and looking at how well did these function. But I think there's going to be the how do we apply these things? Where do we apply these things? And again, how do we measure and make sure that they're actually achieving the outcomes that we want, right? Because you can train an algorithm, you can run an algorithm, and you can think it's working great, but if it turns out you're actually missing things or introducing bias you don't understand, that creates pretty substantial problems. But I mean, we've seen it in everything from document validation to biometric verification to looking at log data and doing the kind of server side evaluation that my colleague here is talking about, Beatrice is talking about, to really identify what some of those anomalous potential transactions are as well too, and be able to hopefully build in place the rules that you need to stop those and shut those off. So again, it kind of shifts the posture a little bit, but the challenges and risks and issues associated with each one of those usage is going to depend on the data that you're using, how good the data is, how clean the data is, whether it's been sequestered for accuracy or whether or not you're just hoping that it's good data and hoping you're building your algorithms effectively. So.
Testing to see whether the algorithm is recognizing the bubbles or the insect.
Exactly. I mean, I think it's a fantastic example of you thought you were training it to do one thing and it was actually doing something completely different.
Yeah, I'm 100% going to use that example. I love it. The idea that we need to figure out how to train these systems to do what we want them to do, and that we are kind of guessing about whether we did that. Is that reasonable in some of these more sophisticated? And I'm particularly thinking about, Ryan, what you were saying about developing the best ways to test these systems. And I realize I'm throwing something reactive at you that wasn't on our list. But I'm kind of interested how you're approaching that, given that the data is messy. And you were talking about synthetic data being used to test systems that are trying to detect synthetic data is really hard. How do you think?
I can't say that we found a way to do that. But again, I think we have a really good example with the way formerly FRVT, currently FRTE works, right? We have good, known, solid data on the NIST side. And just to be clear, earlier when I was talking about the issues of data, wasn't suggesting that NIST was going to open up and provide their data to everyone because we can't do that. But we have the testing program. We have the ability for folks to provide their algorithms and to run that against data that we know is good and data that can help kind of evaluate that performance. The challenge is going to be from both a standardization perspective and a prioritization perspective is what do we test? How do we test it? What needs to be run in kind of open tests? What are going to be run by vendors themselves as they kind of evaluate and test these programs? What are the most appropriate methodologies, right? We've got good standards around biometrics, many of these other applications, we don't necessarily have the same degree of standards and testing methodologies that we can apply to them. So, I mean, I would love to sit here and say that we're going to have really robust testing methodologies for all the applications, and that's simply not realistic or accurate. But, as we start to go through from an identity perspective, we might be able to identify key areas, again, looking at things like document validation and verification and the work already being done at FIDO for maybe that's the next step in some of our open testing programs, and what might be the next step around some of the other things that can be and cannot be tested. We've had lots of internal debates and conversations about things like risk analytics tools and how can we potentially put together something like FRBT or something similar to try and or challenges or hackathons, but the data issues are just so overwhelming as far as being able to have that good testing data set. So if folks have ideas on that, we are very much open to discussing it.
Beatrice, I saw you like nodding along. I'd love to know what you think of this piece.
I think this is where NIST is the perfect entity for this. I have a few friends who work in various organizations trying to do that. It is the work of a lifetime, and it will be the public good of the century, is my professional opinion. This is not Okta's opinion, this is my professional opinion as an AI professional, that this is the standardization of AI algorithms, because it's about the task, and there is an infinite amount of tasks. That is definitely something that our society in general should put effort into generating, because us as a company, the task is so immense that we would never be able to do it by ourselves. So it is a society level side of efforts.
Good luck, us.
Yeah.
So for both of you, again, can you talk a little bit, this is on a slightly different note, but you did mention earlier some of the challenges with facial recognition technology and making sure your data is representative. Can you talk a little bit about how folks are using kind of proactive approaches to tackle broader bias and accuracy issues beyond the testing piece we were just talking about? I think that there's a real cybersecurity angle and security angle to that representation, and making sure that systems aren't introducing unintended bias, even though the role of the system is to be biased. Do I want to let you in?
I mean, I would say there's only two real things that you can do. It comes down to your training data and making sure that is as reflective as possible of your user population, and then you have to have the testing. You have to be able to say, look, we're going to do algorithmic testing, we're going to do operational testing, we're going to do in-flight evaluation of how we're performing. And I think, unfortunately, that's kind of the only real way to get down to what is happening once things roll out into the real world space. So, I mean, within 63, Rev 4 was in draft. We started to touch on this concept of how do we actually, at least from a biometrics perspective, get folks to start looking at not just testing for the overall performance, but potential performance across different groups and different demographics. There's going to be challenges there as well too, because we don't, again, kind of going back to the privacy anchor, you don't want to have folks in the name of efficiency, security, and even potentially inclusivity go out and start violating privacy in order to test their data or get better data and using stuff in ways that's inappropriate. So again, I think it'll ultimately boil down to, from an identity perspective, figuring out what that task is that you're using it for, getting the right representative data to make sure you're actually representing your population, and then making sure that you're doing the various different kinds of testing you need over time to actually get to where you want to go. I mean, that's not the most amazingly attractive answer, but I think that's probably where we're at.
I was really hoping for shortcuts.
I mean, I would love to create shortcuts, but I don't know that I have any at the moment. Plus, I'm not actually a data scientist. I'm just playing one for the moment. So,
okay. Well, the NIST risk assessment framework is a great starting point to help data scientists developing those muscles of checking your data beyond. And I would actually nuance it a little bit. I would say even the training data is not your friend in that case, because you could have extrinsic factors that modifies your data in a way that essentially the data is biased. You're trying to unbias the data. So you yourself has to be aware of those biases. This is the hardest part, is you as a data scientist have to do this self-assessment of what are the biases that we are capable of calculating and those that we are not capable of calculating. There are things we, right now, or maybe in the future, we'll never be able to calculate, but for a lot of things, we can.
All right. So I think we have talked faster than I expected. Let's go down and ask one more question for everyone, and then we'll open it up to Q&A. I'm really interested in making sure, as I said at the top, that the good guys can outpace the bad guys in this particular arms race. And I'd love to hear, a little bit more or other ideas on that particular dynamic. How do we make sure that folks who are trying to secure identity really can pull ahead? Kim, would you like?
Sure. I mean, for the Congress and the federal government, the answer is often money. So I think that what holds back this issue a lot is that because our identity is so often verified by the state that doesn't have that much money, we can be dealing with some really old technology and those kind of issues that, again, we need to throw money at to help them make those upgrades that we need to help secure identities. And even on the unbiased training set issue, I've heard thrown around the idea of like, maybe the government should step in and try to help with this more, because if you're like a small little startup, it is so expensive to get your training data, so it harms competition. Again, like we can't really trust you to make it unbiased, especially if you're doing something like, I don't know, deciding whether to issue someone a loan. That can be really detrimental if you do end up having bias in your data. So I think that those are kind of, I guess, two examples of how we just throw money at the problem and hope that someone with more technical knowledge can kind of figure it out.
Money.
I'm never going to argue with money, but I would say, I think one of the things that we can start to do, and I think Jeremy kind of hinted at this in some of the conversations about our government grading earlier, is starting to think ahead about what are the actual attacks, right? I mean, rather than kind of getting into the churn of simply looking at AI and ML as tough and hard, what is it that we really need to focus on from a security perspective? We hear a lot about deep fakes, but what is the attack we're worried about? What is the attack that might get perpetrated? And how do we go ahead and apply the controls that we need to defend against those things? What is it that we are specifically worried about folks getting through our identity systems with? And what are the controls we can apply? We might not have the controls right now. We might not know the attacks right now, but I think the more we start to think about the possibilities that AI brings to the table, we can start to thinking about what that attack surface looks like and how we can potentially mitigate some of those things more broadly and prioritize our efforts, right? Because we could spend a lot of time focused on trying to come up with standards for something that it turns out is not what our adversaries are really using as the kind of primary focus. So the resources obviously be great, but also being able to really start to think ahead to what the attacks are that we need to worry about and prioritizing our focus and effort there.
For me, I think it would be collaboration. The very interesting thing about AI applied to cybersecurity specifically is that the stakes in that application of AI are probably the highest among all of, AI applied to retail to target you with an ad. But AI trying to protect the access to your bank account, a little bit higher stakes. And that requires two types of very specialized and unfortunately very siloed expertise, which is both the AI and the cybersecurity. The overlap of those two skills are actually, this is not a Venn diagram, it's two bubbles. There's specifically in data science as well, there's a lot of, we look at things in completely different sphere. In security, certainty is the holy grail. Machine learning is all about probabilistic model and living in the gray. So you see already how we are going into two different things. So to be able to build those models, if you give me money and you give me data and an objective, I still have to collaborate with security experts, me as a data scientist, other AI researchers, etc., in order to be able to produce those models that are satisfactory from a compliance perspective, a risk perspective, a performance perspective from the risk. We all have to learn to live in a world where AI is never going to be 100% performant. And that, I think, is a big culture shock for cybersecurity people. But on the other hand, the AI people have to learn to be more rigorous with the security aspect. So we kind of have to learn to bring those two bubbles together
I think that's a phenomenal point. And one of the things we've talked about with 63 and Vision 4 is like the idea of everything needing to be more interdisciplinary overall, right? Like we shouldn't just have our identity folks setting up our identity system and our AI folks working on our algorithms and our, our privacy folks, trying to fight their way in the door to make sure people are paying attention to what we need to do from a privacy perspective. These really need to be cross interdisciplinary teams where the application of the technology and the team supporting that application with policy are all supporting each other and understand what's happening so that we aren't sacrificing, it doesn't have to be mutually exclusive. If we're collaborating correctly, we can actually get these things done in a way that supports
Absolutely.
multiple
And
outcomes.
something that's very important for the industry and for government agencies to understand is that the age of the one-man skilled person who can do it all is dead. We can't have someone who knows both very advanced AI skills. Maybe they exist, I don't know. Maybe you are here in the room and I'm sorry, I did not acknowledge you, but the grand majority of people will have like one very advanced set of skills. And so we have to accept that it takes a village.
I love it. And I think that is actually a fantastic strategy. Let's fund a clearly prioritized set of projects together.
Yeah.
We fixed it. With that, I think we have a little bit of time for Q&A. So if anyone has any questions on AI and identity, I see one in the back.
Yeah, this is mostly for Ryan. So one of the things that AI means for identity is we can't go 10 years.
We've got some online folks, if you can. Yeah.
We can't go 10 years between updates to the standards. So how are you thinking about being able to be more adaptive, as technology becomes more rapidly innovated, as threat landscape changes more rapidly because of AI?
I mean, so that is a perfectly fair and perfectly legitimate concern with the way standards work. And so one of the things we are thinking about with 63 and that we're already seeing with the way 853 is being run is trying to create the ability for more timely updates to our underlying guidance, specifications, and standards. With 53, they've established a new ability to basically submit, review, and add a new control within the control catalog within a few weeks, if it's critical enough. We need to establish that same capability within 863 in the future. We need to get 4 out and done and stabilized, but once that's out, I mean, completely agree that we need to have that capability to update more consistently as technology evolves. I mean, we're talking about AI right now and passkeys earlier, and the application of these things to identity. And a year ago, when we released the draft of Rev 4, some of these things weren't even firm, right? So we need to have that capacity. We're looking at new kinds of publications that might be able to fit in. We're looking at new ways to potentially adhere or update the guidance in flight in ways that can better keep pace with technology. So we hear you, we understand, and we are actively trying to figure out the best way for us to do that within the constraints of how NIST functions.
The other thing that I would ask a question about, and it's more maybe for some of the audience members that I see in the room here. So, having been one of the key leaders of digital identity at Capital One, I can say with certainty that there's no major financial institution that's not using AI as part of their identity stack today, and have been for a while. Because it's kind of you've got to use those tools now, or you're going to be overrun or left behind with how sophisticated advanced fraud is. Similarly, all these major financial institutions also measure disparate impact across their fraud models to make sure they're not driving unintended bias. So it's not as if, because we're now trying to introduce these things in government identity, that we're creating fire. And so I'd say it'd be good to go and engage some of the banks and follow their practices around performance testing across all of the identity stack, because it's like well worn today in terms of how the industry does it. So government should look to some leaders here from Bank of America, US Bank, others that I see in the room who have this kind of experience performance testing. Because if government is buying these things off best value, which they should, then they're going to need to understand performance to make that equation work.
And if folks have really effective testing and evaluation programs and would like to talk to me about it, I'd be more than happy to do so. We need to fill the air. I did want to make an entry to the sock category here. My son asked me to make sure that I showed these off. These are Tweety Bird. He bought them for me last year so.
That's pretty good.
Very nice.
So curious on the topic of disinformation and content authenticity, if there's been much following and support for the C2PA, the Coalition for Content Provenance and Authenticity, that a bunch of organizations have gotten behind, industry association, you got Microsoft, Adobe, New York Times, BBC, it's been going on for years. So it's addressing this whole issue of, disinformation. And I think we all realize that AI is probably just going to make it worse. Just curious if the government is got any comments on this, are you participating in it? No.
It's a little out of the scope for the work that I do. I can't speak to what our AI program team is doing. I'm sure they're at least aware of it, so.
Yeah, in Congress, disinformation, misinformation is obviously a big concern. Gets super political, especially when some members are themselves trying to push mis and disinformation. But I'm not familiar too much with the coalition you mentioned, but it's definitely something that is on everyone's mind.
Yeah, I will say I work with a bunch of folks who are thinking about the right approaches for that, and the organization does come up. But I do think it is a piece of the puzzle, but a little bit distinct from the identity. Maybe we'll see.
There's an identity component to it for sure.
Yes.
Binding the author, the publisher with the content itself. It's something that's I think they're looking at.
All right.
Thank you.
I think. Oh, one more.
Well, what impacts do you see AI having on identity proofing, both good guy, bad guy perspective, on the opportunities and challenges there?
Well, I think it boils down to the fact that, again, it's on the good side, we're going to be able to train fraud tools and fraud detection models to be able to potentially identify a bad actor before you even start the enrollment process. On the biometric side of the house, where that's being used in a technology or a solution, it's going to improve your accuracy. It's going to improve your ability to potentially enroll more users, and to do so in a way that is both more secure and more inclusive for those users. And again, I think then you start to look at being able to look at your log data or looking at your kind of event transaction data and being able to potentially identify whether someone who's trying to get in and execute like an account takeover type attack is kind of showing indications of that threat. So, I think the hypothetical there is that, the continued application of AI and machine learning, particularly to things like fraud detection, fraud analysis, could create scenarios where you're able to apply a little bit less friction, or the friction is a bit more smooth comparatively in the long run. So
let me give you the empirical evidence for this. Of your theoretical intuition is that it is true. Knowing that I'm talking specifically for authentication servers, which is ever so slightly different than identity proofing, just for sake of accuracy. But when we have done studies, essentially A/B testing, we turn on our security AI ML-powered security controls on identification login flows. And what we see is a deterrent effect. So because suddenly when you increase the accuracy of your AI-based model compared to just a rule-based, what you create is a situation where suddenly the bot is more likely to encounter the response. Could be a CAPTCHA, could be any other type of friction added. And what that creates is this friction costs the attacker, especially specifically for authentication. We are talking a lot about low quality, high volume type of attack. So for them, the cent or the thousands of a cent that the interaction costs them, if I add friction to that, for them, it's a lot of friction. So what we see is a deterrent effect, meaning that we have, as soon as we turn on bot detection, for instance, one of our products on the SIAM side, we have a significant decrease. I don't think I can say a number out loud because I forgot if legal has approved it, but it's significant, it's big, trust me. Anyway, so very big on those tenants of all of the undesirable traffic. So meaning that suddenly for the customers, what they see is a much cleaner representation of their users because there's less bots in it. And it does not really affect the friction. So we look at, if I give you a CAPTCHA, you're fine, you'll do the CAPTCHA. But because the system is accurate, the people who see, the humans who actually see the CAPTCHA are very few and far between. So the overall friction for the entire human population is still less. So your intuition is correct. This is what we see in the fact. But I think the deterrent effect, this one is the most crucial because sometimes in cybersecurity, we often talk about security controls. The performance of the security controls, as in is the CAPTCHA good at stopping bots? But that's not the same as the fact that I just have CAPTCHA, like a lock on a bike. I'm not trying to pick the lock, but just I see the lock and then I'm going to move away because it deters me. And that is a different type of performance of the security control, but it's, I believe, as important, specifically when we are talking about AI systems, because of their ability to move with the trends, to self-heal, to have those statistical understanding of what's happening rather than just a hard-coded waffle, for instance.
Great. Thank you. And thank you all. I will turn it back to Jeremy.
Thank you, everybody. We're going to be on break for the next 20 minutes. We'll return at 3 for the Director of FinCEN, Andrea Gacki. Thanks. If I can ask everybody to take their seats, we'll get started with our next speaker in just a minute. Thank you. Everybody wants to talk.
One comment about your numbers.
Yeah.
We're using about 300 billion for the year.
Uh-huh.
Redneck math puts that $1,000 per person.
Yeah.
Maybe kind of hard to say, you know, comprehend that.
I don't think it's a person. I think it's bigger values.
At least, though,
yeah.
it's at least $1,000.
Yeah. No,
Person a year.
it's an unfathomable number, but when you actually
Yes.
look at what's been documented, I think that's the point. Is it's actually that big. So, yeah, it's not necessarily that it's $1,000 stolen from every person, but from the system at large.
Well, it would averages out to the person. That's what I'm saying.
Yeah, that makes sense.